Hello everyone, this is Noah Housley with Dynamics Help and example problems, mainly from my own study, but maybe you can get some too. This is an example problem of normal acceleration and tangential acceleration. Unfortunately, I just picked a random problem and ended up being no tangential acceleration, but it'll be a good problem anyway. So the problem states that there's a plane that's designed to not handle any more than 4 g's of acceleration. So this plane is taking a turn, it's like banking in the air, and so it has a curved path. And so naturally, because it has a curved path, there's a normal acceleration going to the center of the curve. So that was kind of the sum of the problem. It's going at a constant velocity though, which is given. And so there's no tangential acceleration, okay? So what it wants to know what is the maximum radius? So how sharp can the turn be that the plane takes so that the acceleration does not exceed 4 g's, or else the plane would break apart. So this is a very applicable problem. Okay, so how I'm going to solve this is, since there's no tangential acceleration, my total acceleration just becomes the normal acceleration. And so my normal acceleration, this is total, not for tangential, total is just going to be equal to the normal acceleration, which is the v squared, which is constant, over the rho. And it is not changing in this case because it's looking for a maximum. So we solve for the radius. And this is just kind of easy. 4g, so 4 times 9.81, equals 240 meters per second, which was the velocity given by the plane. Square that, divide by rho, switch them, and this is our solution. And I didn't work that out, but pretty simple. Simple problem. If, I'm going to change this a little bit, if there was a tangential acceleration, that means that a total would equal a tangential plus a normal. So this means what we would need to solve this would be, if we still had v squared over rho over here, my v squared is now changing. So I wouldn't be able to use just the constant velocity here. I would have to use, they would either have to give us a time, so that's one thing we would need, a time at which this velocity is acting, or an equation for velocity where we could do separation of variables. We would also need this equation is just the tangential acceleration vector. Here we would also need either an equation or somehow we can solve the velocities for what either given a tangential acceleration where it's saying it's accelerating at this constant acceleration, or just by saying that it started with this velocity, ended with this velocity, and then we could use kinematics to solve that. So when the acceleration is constant, then we can use kinematics, but if this wasn't constant, then we'd have to use separation of variables, like I said before. For this one, I'm kind of second-guessing myself. I don't think you needed to use separation of variables if this wasn't constant. I think you would just need the time and or position at which this is asking for the normal acceleration, because it'd be different around each point of the circle. Okay, so that was a really quick example. Hopefully you enjoyed it. Tell me if I did anything wrong, and comment if you have any questions or things you would like in these videos. And have a good one.